In this lecture, we discuss about differentiation under integral sign. It is denoted by DUIS. The technique of differentiation under integral sign, also known as Leibniz rule, dates back to Gottfried Wilhelm Leibniz in the 17th centuries. However, it gained significant attention in the 20th century due to its extensive use by Richard Feynman, the Nobel Prize winning physicist. Feynman popularized the method in physics and mathematics, particularly in solving challenging integrals that were otherwise difficult to evaluate using standard techniques. Feynman learned the trick from an advanced calculus book during his college years, and he used it extensively in quantum mechanics and statistical physics. The method was crucial in deriving many integral results and played a role in development of Feynman diagrams in quantum field theory. It is useful when the direct integration is not possible. In this rule, the function is depending upon the one variable and one or more parameters. If we use differentiation under integral sign, then the total and partial differentiations, both the derivatives are used. There are two rules of DUIS, means differentiation under integral sign. Rule number one is used when the limits are not the function of parameter, and rule number two, which is also known as Leibniz rule, is used when the limits are functions of parameter. Some standard result like integration of sin x upon x under the limit 0 to infinity with respect to x, which is equal to which is given by pi by 2, can be obtained using the differentiation under integral sign. So let us see what is the meaning of differentiation under integral sign. Differentiation under integral sign, DUIS rule number one. Let I of alpha, which is equal to integration of f of x alpha under the limit a to b with respect to x, where a and b are constants, are parameters, then derivative of I with respect to alpha, which is given by integration of under the limit a to b of f of x alpha, derivative of f of x alpha with respect to alpha, and whole integration with respect to x. Now, differentiation under integral sign DUIS Leibniz rule, or it is also called DUIS rule number 2, which is given by let I alpha is equal to integration of f of x alpha under the limit a alpha to b alpha, means a depending upon alpha and b is also depending alpha with respect to x, where a and b are functions of alpha, then derivative of I with respect to alpha, which is equal to integration of derivative of f of x alpha with respect to alpha under the limit a to b with respect to x plus f of b alpha into derivative of b, means upper limit with respect to alpha, minus functional value of the given function at lower limit, means f of a alpha into derivative of lower limit a with respect to alpha. So these are the two rules which are called differentiation under integral sign. So clearly here we are differentiating this I, but the I is nothing but it is an integration. So now it is the derivative are used inside the integral sign. Therefore, it is called differentiation under integral sign. What are the different properties of differentiation under integral sign? So the first property is differentiation can move inside the integral. Instead of differentiating the entire integral, we can bring the differentiation inside and apply it only to the function being integrated. This is the first property. The second property is works even for infinite limits. The method can still be used when the integral extends to infinity, making it useful in physics and probability. The third property, have solve complex integrals easily. Introducing an extra parameter, differentiating, and then solving often simplifies difficult integrals. The third property handles changing limits. If the integral's starting and ending points depends on variable, this method adjusts for those changing while still allowing differentiation. Fifth and the last property, used in many important functions. These techniques help in solving special functions like gamma function, beta function, and error function, and is widely applied in Fourier and Laplace transforms in engineering and science. So these are some very basic and very important properties of differentiation under integral sign. Now, what are the applications of differentiation under integral sign? So let us see one by one. The first application is solving difficult integrals. Used to evaluate integrals that have complicated form or cannot be solved by elementary techniques. The second one is in the quantum mechanics, appears in path integral formulation, particularly in derivation of propagators. The next property is in statistical mechanics. It helps compute partition functions and thermodynamics properties. The next property is electromagnetic theory. It is used in Green's function calculation for solving Maxwell's equations. Special functions. It applied in deriving Bessel's gamma and beta functions. The next applications is in probability and statistics. It is used in probability distribution to compute movements and cumulative distributions. Signal processing. It plays a role in convolution integrals and Fourier transforms. Fluid dynamics. Applied in solving Navier-Stokes equation in boundary layer problems. Heat transfer and diffusion problems. It is used in deriving solutions to heat equations and diffusion equation. In mathematical biology, helps in modeling population dynamics and enzyme reactions in biophysics. So these are some different applications of differentiation under integral sign. Thank you.